All right, so happy Tuesday. Today is test week. Yay! It's test week. Okay. So we will open up the test for you on Wednesday afternoon, and you will have until Monday the 19th at 11:59 p.m. to get that done. Now, one thing I will warn you about is if you are a procrastinator, like many of us are, including myself, if you wait until Monday night to take that test, the testing window closes at 11:59. So wherever you're at in the test, if you're still taking it at 11:59, that's going to close right then. So okay, so wherever you're at, that's where it's going to be. So the topics that will be included on the test, we will have some graphing of exponentials, some graphing of logs, some graphing of logistics. We will use properties of logs to expand and condense the logarithmic expressions. We will evaluate some logs, building exponential or logistic type functions, and there will be a lot of solving exponential and logarithmic equation problems on there. Okay. So today and tomorrow are going to be review days. I think it's 5 examples to go through today, and then tomorrow we'll have some more examples and questions and answers abounding. There is also a review assignment that was assigned yesterday on It's Learning for you to start working on. Okay? So let's dive into it here. Okay? So we want to solve these for exact answers only. Now there's a couple of different ways that you can think about this. Okay? First way to think about this is we could add the natural log of 5 to both sides. And then that would give me the natural log of x equals the natural log of 5. And since my base or my logarithmic equation is the same on both sides, then the arguments, the purple arrows here, have to also be equal. So it would be here x equals 5 would be my answer. The other way of going about thinking it is, well, you could utilize your your logarithmic properties, and since we're subtracting with the same base here, we could make that be x over 5 equals 0. So the natural log of x over 5 equals 0. Then I could switch forms with it, and I could say that this is e to the 0 power equals x over 5. Well, anything to the 0 power is 1. Multiply both sides by 5, and then I get my x over 5 part. Okay? So we have that as an option. Okay, so a couple of different options there. In number 2 here, okay, we have an exponential equation, or an exponential term, or an exponented term, I think would be the best way of saying it. We have an exponented term equaling a number, so we could switch forms with it right away if we wanted to. We could go log with a base of 2/3 of 81/16, and that's going to equal x. And then I could use change of base formula, log of 81/16 divided by log of 2/3. Or if I had a fancy dancy calculator that allowed me to type right in what the log base 2/3 of 81/16 is, we would get -4 equals x. Okay. Now, another way to go about thinking of that same exact one would be to say, oh, well, I'm kind of looking at these and I'm thinking, okay, I've got 2/3 to the x power, and I've got 81/16. Well, 81 is a power of 3, 16 is a power of 2. They're both to the 4th power, so this would be like 3 to the 4th power over 2 to the 4th power. Still not 2/3 yet, but this would be like 3/2 to the 4th power. Still not 2/3 yet, but if I remember, I can reciprocate if I negate my exponent. And now I would have 2/3 to the x power equals 2/3 to the -4th power. And since we have equal bases, then those two would have to be equal. Okay? Just another way to go about thinking that today. Okay? The question of the day today is, what really makes you angry? Okay, so if you are watching this video at home, please send your grading teacher the answer to what really makes you angry. In class, a lot of people were saying siblings and slow drivers and things of that nature. Okay. We can also evaluate different expressions based upon their certain conditions. Now, I like to do these a little bit different. I like to put them equal to a box, because if I have that equality and I have that box, then what I can do is I can change forms with it. So this left one is in logarithmic form. I can change it to exponential form. So I could say that this is, my log base is e. So I could say e to my box, because that's my exponent, is equal to my argument, which is e to the 10th. So in order to make those equal, that box needs to be filled with 10. So the natural log of e to the 10th is 10. Natural logs and e to a certain power, those are inverses of one another. So those cancel each other out. So the natural log cancels out the e, leaves me just with 10. Okay. Likewise over here, if I set it equal to a box, well, now I'm in exponential, or it's an exponential equation, so I need to switch it to a logarithmic equation. So I would have log, my base is 5, my argument is that box that I'm looking for, and that's going to equal my exponent. Well, my exponent is log base 5 of 7. So in order for those two equations to be the same, I would need to fill the green box with 7. Okay. Next example here is a word problem, coming up with a logistic function type word problem. So for those of you at home, I would like you to now pause the video, do this example to test your knowledge on it, and then restart the video, and I will continue on with this particular problem. All right, so our logistic function would be of the form f of x equals c, our limit to growth, over 1 plus a b to the x power there. Okay? So the limit to growth, that's going to be this one right here at its peak. Okay? So that's going to be c. Okay? So that if that's c, then this one, when we started, measured 11 inches tall, that one is going to be my initial value, 0, 11. So I'm going to use that to find either A or B. So if I have 11 is my y value, my f of x value, equals, well, c is 33 over, oops, I should really make this colorful. Color-coded, over 1 plus a b to the x power. The x part of that point is 0. So really that's just 1 plus a on the bottom down there. Okay? So we could say here 11 equals 33 over 1 plus a. Now I can flip-flop that 11 and that 1 plus a. It's a math trick. I'd multiply both sides by 1 plus a, then divide both sides by 11. So I get 1 plus a here equals 33 over 11, or just 3. Subtract 1 from both sides, and a is 2. Okay. Love it so far. Then the last part that we have is the fact that after 1 month, it grew to be 22 inches tall. So it's going to go through the point 1, 22, and we're going to use that to now find our B value, because we have C and we have A already. So now that's going to be 22 is equal to 33 over 1 plus 2 b to the first power. Again, I can flip-flop the 22 and the 1 plus 2b. And so then that would be 1 plus 2b is going to be 33 over 22. 33 over 22 reduces down to 3/2. Subtracting 1 from both sides gives me 2b equals 1/2. Dividing by 2 is the same as multiplying by 1/2, gives me b is 1/4. So my function, my tomato function, if you will, t of x is going to equal 33 over 1 plus 2 times 1/4 to the x power. Okay? That is the 5 examples that I would like to, or that I wanted to go over with today. But before I let you go, I would also like to talk to you about 2 more things. First off, where do we go from here? Okay. Well, so for the up until you take the test, we can go back and you can go back and do the formative assessment that we had last week. If you didn't get 100% on that formative assessment and still have an opportunity to retake it, like lots of people in my grade book at least have, that's a spot to go back and a good review to go back on from the earlier sections. There's also a homework from earlier last week. I haven't graded mine yet as of this recording, but that was my plan for later on this afternoon, was to go through and grade those. And then there's the review worksheet, which is on It's Learning and was assigned yesterday for you to do as a review and submit that by next week, Monday. Again, the test will open up Wednesday afternoon, Wednesday the 14th. The test will open up, and we will have that open and ready to go for you, that one. The last thing that I wanted to talk about is something that we actually talked about way back in, on September 28th, so a couple weeks ago, just to remind you that this class is a dual credit class through NTC, and you should at this time go and get yourself registered in trigonometry with applications through NTC. There are some videos here on September 28th that will remind you or inform you. One to talk about what dual credit is and what a great program it is. Another one to talk about if you already have a username and password but you forgot what they are at NTC because you might have taken a dual credit class before. Another one here is how to create your NTC ID if you've never taken a dual credit class before. And then finally, how to actually enroll in the actual class. Enrolling in the class does not lock you in to taking the credit at the end of the year. It just affords you the opportunity to take the credit at the end of the year. Okay? You have the option to opt out at the end of the year, but you don't have the option at the end of the year to opt in without registering now. Okay? So please register now. It doesn't hurt. It doesn't cost you anything to register now, but the benefit is at the end of the year, you might get 3 college credits to apply to any college or university in the country. Okay? That's all I got for you. Thanks for playing along. We'll do some more reviewing tomorrow, and we'll see you next time.